Okay, so we're going to go back and do systems of equations much more thoroughly now. So here is a system of equations. The way I know it's a system of equations is this weird brackety squiggly guy. Weird brackety squiggly guy means that this is not just one line, this is mx plus b, right? But two lines, and we're supposed to think about where the solution where both of those lines occur simultaneously is. That means simultaneous, in other words, in mathematics. Okay? So simultaneously, where are these two lines both the same at the same time? Okay? So there's all kinds of ways to solve systems, and systems don't just involve lines. You can do a line in a parabola. I bet you'll see that on Park. You can do a line in an exponential function. You can do a line in a trigonometric function. There's all kinds of functions. Does that make sense? You can put any kind of function in here and do this kind of thing with it. So we're just going to focus on two lines at a time. We might throw in a parabola or two toward the end, okay? And we're going to learn different ways to do it. So the first way to do it is graphically. So let's do this graphically by hand. You're also going to see a couple problems that just say, like the election this year for the president, they give you a candidate point, a candidate answer, a candidate solution. And they say, is this guy a solution? Well, how do you know if this guy's a solution to the system? You plug it in. Perfect. And how many of them do you think you have to plug it into? Both of them, because it's got to work for both or it's not an answer. Let's plug it into this guy. It doesn't matter what order you go in. So if I go 2 times the x is 1 plus the y is 2, is that going to work? Well, that says 4 equals 4. So yes, it worked in the first line. If I go and take it and stick it in that line, is it going to work? Well, let's see. Y is 2. 1/3 times the x is 1. So that says 2 equals 1/3. So that's just times 1 minus 3. What do you guys think? 1/3 minus 3? Is that going to be 2? It's going to be a negative number and some kind of fraction. Yeah, exactly. I think it's going to be negative 2 2/3, in fact. And that's definitely not 2. So is this candidate going to be elected to the office of solution?
No.
The answer is no. Okay, so guess and check is not a good way to do systems. But you're going to have some problems like that, okay? So the first way, the only thing we're working on in this section is solving them graphically. Now you can use your calculator for that, and you can do it by hand. You need to know both. If you don't know both going into next year, you're going to have trouble. So this guy, graphically, is it ready to graph right now? A lot of yours will be. This guy's almost ready to graph. Why are you saying no? Let's do it.
Because the bottom of the system isn't in slope.
Yeah, exactly. This one we've got to move something. This one's ready to go, so let's leave it alone. Don't get lazy here and not write this down twice. Your work should look just like mine. We're very close. So what do we need to move on that one to fit the form?
2x.
The 2x. Great. So we're going to go like that, and then we'll have y equals on that one as well, negative 2x plus 4. Now it's ready to graph. Let's sketch it and see if we can estimate the solution, and then we'll graph it and make sure our estimate was actually the right one. Okay? So estimating this guy, let's see, first line, we're going to start by going down 3. And you want to try to draw these nicely. If you don't, you'll get really wrong answers. You want to go up
1/3.
Up 1/3. So I'm doing a bad job, but up 1/3, I'll try to do better. Something like that. And the other line, I'll do it in red. I'm going to start at
Positive 4.
+4. We'll go
Down 2 over 1.
down 2, because there's an over 1 here, down 2 over 1. So if you use graph paper, this will also come out much better. So I encourage you to use graph paper. If you want to borrow some of mine, you can. If you use a ruler, it'll come out nicely. Doing it on the board with grease markers is probably not going to be the best answer. So what do you guys think the answer is for this system?
2.
I'm going to say like 2 to 3, something like that. Maybe like 2.5 and negative 2, you guys are saying? Something like that. Mine is pretty sloppy though, so that's probably not exactly it. So let's confirm our answer with the graphing calculator. Remember, you need to know this both ways. So putting my stuff into the graph on the calculator. Miss Collins, you following me? Y equals. If you got stuff in there, clear it. I think we had some parabolas in there. All right, 1/3. So I'm going to just use parentheses. I'm going to go parentheses 1/3 x minus 3. And then I'm going to go negative 2x plus 4. And before I hit graph, I should hit zoom what?
Zoom standard.
Zoom standard. See if this looks like I sketch. Hopefully. Pretty close, right? And now let's have the calculator find the exact spot. We'll see how close we were. So, I think we've done this before. By next year, I'm not going to remind you at the beginning of the year. I'm just going to do it. So, I go second what? Calculate. Very good. Second, calculate. And which one of these things do you think I'm interested in? The intersection. Use common sense. And then it says first curve. Remember, we do like the left, right, middle thing. Even if it doesn't say that, just do it and it'll never mess you up. So get kind of close. That's the left side, right? That's good. I'm going to scroll the other one to the right side. Somewhere over there. And I'm going to guess as close as I can. And it says the actual intersection is 3, negative 2. We were really close. But no cigar. If we'd have plugged that in as a candidate, it would have failed. It'd be close, but not quite. Okay, so there's how to do a system of equations graphically by hand and by calculator. So that's what's in this section. That's it. I'll show you like an application or two tomorrow, and then you guys will have some work time.